physics is real. So let me show you what I really mean. Here I have tubes of different radii. This is the widest and this is the thinnest. I'm going to pour some colored water in this trough. Note the level of water in each tube. What do you see? The water rises most in thinnest tube and it rises least in the widest tube. We can make sense of this based upon energetic considerations. Remember, the reason the fluid rises is because the adhesive energy between the glass and liquid is higher than the cohesive energy between the water molecules. However, there is an energy cost for raising the fluid to a certain height. Note that the gain in the energy due to adhesive forces is only for the molecules that are in contact with the surface, whereas the energy cost associated with raising the molecules to a certain height is for the whole volume of liquid column. Therefore, the balance between energy gain due to wetting and the energy cost due to raising the liquid determines the equilibrium height of the column. It is clear that since very little liquid is in the bulk in the thin tube, which is not in contact with the surface, the energy cost for raising the liquid in this case is relatively smaller than the wider tube when compared to the gain due to wetting the The Tim Tam Slam also uses the physics of capillary action for fun with biscuit dunking. The physics of dunking is driven by the porosity of the biscuit and the surface tension of the beverage. A biscuit is porous, and when dunked, the capillary action draws the liquid into the pores between the crumbs. The trick here is to decrease the surface tension and increase the viscosity of tea. Lesser the milk, more is the surface tension of tea. More is the sugar added, more is the viscosity. It turns out that the dunking time of the biscuit is inversely dependent on the surface tension and directly proportional to the viscosity of tea. So the trick here is to add more sugar and less milk so that the biscuit lasts longer in the tea.